Alrighty. We are set to go. We've got around 30 seconds left. Incoming day 13. I haven't yet gone back and automated anything from day 12, but again, that'll probably come later. Three, two, one. Here we go. We got crops and carts. We're mapping out the tracks of the carts. This is similar to another one that was like this from last year. Intersections occur when two perpendicular paths cross. It is capable of turning on that intersection. The carts are also on the tracks. Carts always face either up, down, left, or right. On your initial map, the track under each cart is a straight path, matching the direction the cart is facing. This is getting very complex already. Each time a cart has the option to turn, it turns left the first time, goes straight the second time, turns right the third time, and then repeats those directions start again with left, fourth time, etc. This process is independent of the particular intersection at which the cart has arrived. That is, the cart has no per-intersection memory. Right, it's just deciding each time which way to turn. Carts all move at the same speed. They take turns, moving a single step at a time. They do this based on their current location. Carts in the top row move first, and carts in the second row move, then carts in the third row, and so on. Once each cart has moved one step, the process repeats. Each of these loops is called a tick. So we're just going to keep running it, basically, until two of them collide. The carts eventually crash. To prevent crashes, you'd like to know the location of the first crash. Oh, boy, this is going to be weird. Okay. Thankfully, one of the interesting things about this is that, well, we'll see. Okay, as we go along here, this should be fairly easy to track. It's mostly just a matter of managing state, and they're going to have, these carts are going to have a fair amount of state with them at all times. We're going to get our puzzle input, which looks like, holy cow! Oh no! That's insane. Oh man, simulating this is just going to be horrible. Like, okay, well, let's write this out. Oh, good grief. I'm going to actually need to keep this on like a main tab instead of off to the side this time, because this is a useless view. All the word wrapping is screwing it up badly. Okay, let's go ahead and run you. Look at that. That's weird. Okay. Oh, I see what it is. Okay. Okay, I get to bring out this old thing again. Okay. Next turn. This is just kind of defining some of the things that we already have. Oops. Okay. Let's validate that. Left, straight, right. Left, straight, right. Okay, we're good. We're going to map the plus pos and dir to offset of dir. So I can say, for example, move bingo. Looks good to me. Okay, let's get our big grid basically is going to be oh, not gird. Cool. So one thing we can tell here, let's see, over left, going left on that gives you down, going up on that turns you right, going down on this turns you left, going right on this turns you up. Similarly for the other set. I think that works. Going left on that turns you up. I'm seeing a pattern here. Going up on this turns you left. Where is this thing? Okay, going down on this turns you right, and going right on this thing turns you down. Good enough. I'm sure there's an easier way to build that, but the map is nice and explicit. Okay, so let's see. I'm trying to think of how to do this. Keys. This is gonna be our cart. We should probably define what a cart is first, just so we can see what this looks like. So as a position, which is an X and a Y, it's going to have a direction that's facing currently. It's got a next turn. We should actually define intersection turn here. So this is given an intersection. Where are we going? Another whole series here. Oops. Okay. Okay, let's bump these out a little bit. Turn left, turn left, turn left. We're gonna say go straight. I don't know how to do rectangular inserts in Emacs yet, but it's quick enough to do it by hand. Okay. Turn. Let's make sure this looks reasonable. So when we left goes straight left, down goes straight down, right goes straight right. This seems kind of trivial, but this uniform form for this map is going to make things a lot easier for us. If we're going left, you turn right, turn up. Down, left. So this is basically going to be the opposite of what we had up there. Okay. I think that gives us all we need. because at any given time, the card has a position, it has a direction it's facing, and it has where it will turn next if it hits an intersection. So I like that. Okay. We also need a grid. Let's see here. Okie doke. So again, this def and split thing just creates a sort of curried function. So I give this input, and it creates another function that takes this input and then runs whatever this is. That lets me just split things up a little more nicely down the road, I believe. We'll see if that happens in this case. Worst case, I take out the def and split, turns into standard def, and we're fine. The big thing here is the grid doesn't change. The grid stays static. It's just the card's moving around on it. So that gives me a little bit of room. No, this isn't what I want, actually. So I don't want to move straight. I just want to move on the grid. So I'm going to let the next cell be so let's see, given our grid, int x of int y of grid. So if I get cell grid 40 and O, vector can't be cast a number. What's nth take? Oh, it takes the collection first. That works too. That's actually much cleaner. Okay. So we're going to get the next cell in the direction that we're facing, which is Oh. Next cell. It's a cell from the grid at that next cell position. Let's see here. Next cart. We're going to associate with the cart. Position being the next cell position. We already know we're headed that way. I mean, frankly, actually, this isn't even association at this point. This is just a new map. What do we call this? This is kind of like after we've moved the cart, we're gonna have to take an action. To give a nice name we can use for this. We're going to apply a track to the cart based on the next cell. And that'll spit out for us a position, which is the next cell position. New facing, new turn, new next turn thing. Okay, so that's what I need to return from that. Not new facing, but new dir. Okay, let's go ahead and define another method here. Method function. We're gonna need keys. Let me think. Dir and next turn. And then track. Instead of cell here, let's use the word track. Next track. That feels better as a name. Okay. So if it's just a straightaway, pow, nothing changed. Similarly, straightaway, another straightaway. If it's that, we curve with our current direction and that character. Again, we might be able to work this out better later. And then our next turn stays the same. Similarly for this, just with this now. Okay. Then lastly, we have this, which is going to be intersection turn of the current direction and the next turn. This is going to be, oh dear, not next, this can't be next, this has to be like update turn. Okay, I like it. Another thing to observe here, actually. We're gonna have to replace some of these things. So we have our carts overlaid on top. I need to be accounting for those. What I'll do here so we're basically going to treat the carts as straightaways. Let's verify that in the problem statement. The track under each cart is a straight path. There we go. We need a way to parse our carts. From a grid. So for Y in count grid, for X in count validate this real quick. Get okay, that works. when, I think it's when. Okay, let's try this instead here. Straight. There we go. So now we have a list of tracks that are straight. We can get a list of tracks that are curves, which is this and this. And we can get a list of tracks that are intersections, which is literally just this. And that means then that this can be made something quite interesting here. Curve. So if the track's a curve, then we're going to go ahead and curve it. Take a look at that. That's a little neater now. Come on. I'm pretty sure this might be con P. No, the predicates comes first in con P. Yeah. I want the flip of that, really. So, oh well. Okay, back over here. 4. Right, because I wanted to do one more here. Def cart. Okay. And that gets run when cart get cell and grid XY. Let pause be XY. Oh boy, another one. Okay, you'll see. This is happening a lot this time. So this is up. This is down. This is left. And this is right. Ta-da, done. Okay, we're going to make this into position, pause. Its direction is going to be this lovely thing we just made with the actual value of the cell. And then lastly, next turn is always starts with left, according to the problem statement. First is always left, yep. I did not like something in here. Let requires a vector for its binding. Okay, I need to actually do this. That's okay. We can deal with that. I did not actually run my fancy new function. Still doesn't like it. What did I call it? Initial dir? Initial dir. Okay. So if I parse the carts from our current grid, yeah, okay. Okay, just to see here, sort by pause. Just to double check that this works as intended, let's see what happens if I sort by pause of 23, 23, 23, 23, 23, 24, 24, 23, 24, 24. That looks good to me. Okay. That tells us what order we need to tick in, basically. Not in the grid, in a series of carts. And we need to know the position of the collision, right? Yep. Carts map to their positions. Take the frequencies of each of those positions. Filter where the frequency is greater than 1. And I think we're good. So, for example, the collisions of POS of 23, 24. POS of 24, 24, and the POS of 23, 24. Nothing, so I didn't do something right. Let's see. Oh, right, you know, as always, it helps if you have your arguments in the right order. There we go. And instead of this, We have to map to first. There we go. So that'll give us the positions only. Because it's all the positions that overlap. Okay. So, in order to... Now, we have... let's see. So to tick all the carts in a grid, you know what? Taking out this old thing, it's gonna make this a standard deafen. I don't see any reason to use the split in this case. Okay. Let sorted carts be sort by pause carts. So that gives us the order that we're going to walk these in. See. So you have to like do something interesting here. Okay, this could be interesting. So instead of just doing this, we do this. See where we're going with this? So we say, here's our new cart. This is actually a little harder than it seems because there has to be a way to coordinate this cart's position in the current list of carts, basically. You know what? I don't like where this is going. I'm going to keep that where it was. Okay, but I am going to say okay, let sorted carts be the vector of carts sorted by their position. We have that back again. Slightly different, but still there. Okay, we're going to do this with the loop recur, I think, just because I have a few things to handle here. So we have carts, be sorted carts. Yes, I'm shadowing the outer argument. I'm not too worried about that. Index O. So if the index is already at the sorted carts count, so if we've already hit the end, we're going Erlang style for this. We made it to the end without collisions, basically, is what we're saying. Whoops, count of carts only. And we're going to send back our list of updated carts. Otherwise, bum, 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 bum. Oh, I'm using assoc in, not assoc. Okay, here we go. Try this again. 1, 2, 3, 1, 5. There we go. That's what I was doing wrong. Okay. We're going to let the new carts carts index. So we're going to say that's our new carts. We're just swapping out the individual cart we're at with the updated cart. And then the collisions are the collisions of the new carts. And the collided is just if it's not empty. So if there are any collisions, we'll notice. If any collided, we'll return back collisions and calls. Otherwise, we will recur. So no collisions. We'll just continue with the next thing with our new carts and an incremented index. That seems satisfactory to all y'all. Oof. Sorted by, but sort by. Okay. Parse carts from our grid. Notice I'm getting nils in here. That's my straightaways. Think. What does that 2878 say? Is it grid cell? Get cell. Oops. I actually should give it a grid, huh? Is an intersection. So it's the intersection part that's breaking, I think. Let's try fixing that. So when it hits an intersection, what's it do? Oh, you know what? Next turn. My initial next turn is broken. My next turn is turn left. Okay. Carts. Let's see. Sort by pause. Carts. Sort by pause. Second of tick carts grid. Carts. I'm no longer seeing nils, so I think we're good. Let's see. Now we just need to iterate. On carts. You think what I'm thinking? This is where I should have it. So see this, and this turns into... I could use partial here, but I just think this reads a little more cleanly sometimes. Drop while so drop while we're seeing that everything's okay. Oh, that's not going to work, is it? So, once again, my hubris has overcome me, and I have made a bad decision. I do not want Deafen Split here, because I need to customize it a little. Second of carts. So we're actually going to start it off with an OK here. We're going to drop elements until we see it's not okay. Okay, we have a collision. Then we're going to grab the first item. We're going to grab the collisions out of that. And that should be it. Okay. Oh, let's see if I do something stupid like breaking the REPL again. 115, 138 is what I get. That was really fast, actually. That was not bad. Okay. There isn't much you can do to prevent crashes in this ridiculous system. However, by predicting the crashes, the elves know where to be in advance and instantly remove the two crashing carts the moment any crash occurs. They could proceed like this for a while, but eventually they're going to run out of carts. It could be useful to figure out where the last cart that hasn't crashed will end up. So, they gave us an odd number of carts, basically, and there should be only one left. This actually should be pretty easy to do. That was really fast, actually, so I'm thankful for that. These kind of simulation ones can be really costly, but it seems like they've mitigated that. This is a whole lot of junk. So what we're going to do here is we're actually going to make a second tick carts, as if this one wasn't big enough already. I could probably do some refactoring on that later. Okay. Quite satisfied with how that one reads. Tick. Tick carts with helpers. So here, instead of just grabbing the collisions and seeing if any collided, we're going to go ahead and unconditionally return salvaged carts. I guess safe carts is filter So we're going to filter the new carts that we have by removing any carts that have collided in this phase. And we just go ahead and move on. As a matter of fact, we no longer need our OK signifier, which is nice. Okay, I like that. So let's go ahead and rewrite this to be look like this. Iterate grid percent. So we're going to drop while greater than, while the count of carts is greater than 1. And we're going to grab the first entry out of that. So this is the last state. This is the only state, or the first state with only one car in it. Then we're going to grab the first cart out of that state. We're going to grab its position. Did not like it because I didn't actually, you know, run that. Fingers crossed. This might take a while longer. Thankfully, I don't see any obvious way to short circuit this one. But at the same time, if my logic is faulty, what I've just done is started an infinite loop where the carts are running forever and never colliding. So that's also a likelihood. Oh, I did! I totally did! This is supposed to be safe carts. Dope. So let's kill the Repel. But I am close. I'm pretty sure this will do it. This is a nice fast one, actually, which is nice compared to the last couple nights. It's only been an hour. That's not bad. Timing's okay. Come on. Come on, line. Yikes, Repel's slow. Did not like. Okay, what didn't it like? Lazy seek. Okay. Oh, you know what it is? Oh no, hold on. Carts is not coming out associative. Turn it into a vector. Ta-da! Done. Index out of bounds. Also here. If greater than or equal to. Oh, this is the classic issue though. Shoot. My indexing gets screwed up along the way. Okay, so I need to figure out how to adjust the index better. Index offset is, so we're going to add and so if a given entry was in the set of collisions and its index is less than or equal to our current index, map. This is technically filter and count. Plus index 1 minus index offset. Doesn't like it. Need to actually apply it to something is the problem. Okay, I have this nice filtering function. And we're going to apply that to new carts as well. Filter does not like it. Oh, but this is the whole thing. This is why I needed map. Ah! Can't get this straight. Okay. Map indexed. Filter ID. Identity. Gross. Look at how long that's gone. Factor thread last. That reads better. Makes that function really long though. $0.98. Come on, come on, give it to me. Not bad on the leaderboard either. So that's a good sign. So whenever you have a star that's a little, pretty good on the first, but better on the second star, that usually means that your first solution gave you enough leverage to your second solution easily. So, this was a good evening for me, actually. Interestingly enough, this is something where Clojure does well. You notice it's not a lot of massive sequence processing, oddly enough, and it's not the, it's mostly just all these associative data mappings that you can make just on the fly. So much of this was data. I'm pretty sure actually the amount of data outweighs the amount of, well, maybe not quite outweighs the number of functions. Still, it's a pretty handy way to encode a lot of these very simple rules. Cool. And once again, I think this is a case where I'm not actually going to change much. I kind of like it how it is. It reads reasonably well. This is a bit kludgy, I think, but I can't think of a better way to handle it on the fly, so we'll leave that as is. Cool! Gonna go ahead and let's save this guy. Stage these. Add day 13 solution in Clojure. Push, and I think we're good to go. Okay, and with that, I think we're gonna call it an evening. Hope you've enjoyed. If you're stuck, hopefully this helped. This is definitely a pretty, a little heavier on the idiomatic Clojure this time, maybe. Although some of the Clojure folks might call me out on that, so. If so, so be it. As it is, enjoy Advent of Code, and keep learning languages, especially Clojure. Take care.